Okay, I think we can then start, and others will join us as we go along. So, Assalamu alaikum, Molweni, good evening, Goeienaand, Mahaha, bonsoir, Mangadif, Baunoite to all our attendees. Massive welcome to all of you from across Africa and across the world. We're thrilled to have you here today. My name is Tokir Ahmed, and you are tuned into the PIANC Africa Webinar Series, your essential source for expertise in global waterborne transport with a unique African blend. PIANC Africa is a collaboration of various PIANC members from across Africa and PIANC COCOM, looking to grow PIANC membership in Africa and also to grow the African voice within PIANC. We encourage the various African countries to take up membership and join this collective. And for those who are here today, if you're not members, we encourage you to become members, and we also encourage you to, invite all your other colleagues within the space in the African continent, so that we can then grow that African voice within PIANC. The webinar is also being hosted in collaboration with PIANC South Africa, the PIANC South African National Section. And we'd also like to send a special shout out to SAICI Marine, who we are working with and looking to then collaborate between SAICI South Africa, our PIANC SA, and SAICI Marine. We thank you for making time to join this webinar. This is our webinar number 4. So still quite early days for us, and we're looking to grow this. But do keep an eye out for them this year. We do have quite a few lined up for you. Today's topic is thought-provoking. It's future defining for the African space. And we are diving into PIANC's guidance on sustainable management of and the navigability, bit of a tongue twister there, of natural rivers. Your working group 236, which focuses on keeping natural or quasi-natural rivers, safe for navigation and maintaining that river, for its form and function. The discussion also aims to show how we can move from fixed, to ad hoc, from fixed work to ad hoc works to an adaptive data-driven, cycle planning, implementation, monitoring. So that's what we're hoping to cover in today's presentation. And, your natural rivers are, the integrated, socio-ecological systems, and ones that we need to look after, for the health and welfare of our society and for the environment also. And so the working group 236, does make a bit of a, step change from the classical river engineering, which we then hope to then cover today as well in today's guidelines. There's not also the only guideline on rivers. PIANC does have quite a wealth of, guidelines on rivers. Our first, or the PIANC number 2, webinar number 2 did cover river information system. So that is, available, online, which we will share later on. And there's quite a few other, working group reports from PIANC related to rivers, which is, they work hand in hand. So you need to have a look at them, collectively as well. So yeah, for those who are joining us, for the first time, we welcome you. Just to indicate that, the core purpose of what we're trying to do here through this platform is now learning and education. Specifically around port, coastal, inland waterways, look at, innovation and smart technologies within the space, and to look at, global engagement and collaboration across, the waterborne transport. So PIANC is global, and to assist Africa, we want to bring in all those, global expertise to help them grow PIANC within Africa and grow the expertise within Africa as well. It's not only, for our colleagues involved in the ports and river systems. We encourage everyone to join. So if you've got, your finances, bankers, decision makers, call in everyone, young students, old students, retirees. We want to make this, open for everyone. So whoever's interested, even if your banker and your accountant, has a keen interest in what you do, invite them here so they can come and see what is it that you do within the space. We also actively, encourage your participation. So as much as I will be interacting with the speakers, we need you, the audience, as well, to interact. This is where you learn. So please feel free to, when the time comes, it will typically be at the end of the presentation. Put up your hand, drop your comment in the chat, raise a question in the chat box. Let's have a conversation. So that's the aim of this. It's an open discussion with everyone. And if for whatever reason you or colleague have missed today's session or the previous sessions, we have loaded them onto YouTube. Today's one it is being recorded. Um, so it'll also be uploaded onto YouTube for you to then, look at or watch at a later date. I will then drop a link in the chat. So look out in the chat. There's a couple of things I'll be dropping in the chat. So do look out for that, link to the YouTube page. And if you are watching this on YouTube, give us a thumbs up, like and subscribe, hit the bell notification down below, and so you'll get notifications to other videos in the future. You do have other sections of PIANC, such as PIANC Australia, New Zealand, who have quite a few bit of content on YouTube also. I'll be looking to link up with them and also list it on the same YouTube page, so that a one-stop shop for Africa is where we can try and get all the information from around the world. And yeah, again, just to iterate that if you're not a PIANC member, we do encourage you to become a PIANC member. I will be dropping some links in the chat as well for you to go and pick up on the membership, and it gives you access to the working group report we'll be going through today, plus all the other working group reports. They are available free of charge to PIANC members. To the public, unfortunately, they are restricted. You won't be able to see the in-depth, and some of these manuals run a couple of hundred pages in length. They are detailed technical information to help you not only with management, but on the design and development of different infrastructures. When it comes to environmental things, you need to keep in mind. So there's quite a bit of a wealth of information there. So being a PIANC member does have its benefits, and then these manuals are then open to yourselves when you do become a member. So let's get straight into the discussion. Let me ask our presenter to come introduce. We also have one of our PIANC Africa members who will be with us on the panel today as well. So I'll call each of you to come through and just present yourself, or just introduce yourself. Tell us who you are, what you do. Uh, I think it's better in your own words. If I try and introduce you, I might not do justice. I might miss something quite important and critical. So let's start with yourself, Kelvin. If you want to just quickly introduce yourself.
Sure. Thank you very much, Ahmed. I'm Calvin Creech. I am the Vice President of PIANC, representing the Americas, and I also work for the Army Corps of Engineers as a river engineering specialist.
Thanks, Kelvin. And then Jean-Marc, just come in and introduce yourself as well, and maybe put on your camera.
Yes. So I am an expert in inland water transport. I've been working with United Nations for years, and I have a lot of interest in Africa and navigable rivers in Africa.
Thank you, Jean-Marc. We do have some questions for you later on, of the presentation, and just to get your views and opinion as well. So we'll call on you at that time. Thank you, Jean-Marc.
But fortunately, there is another person from Africa that may help because he is conversant with the Congo River.
Okay. No, we can get some views from him. Then you can call him through when we get to that point. No, thanks, Jean-Marc.
Yeah. Sure.
Then Calvin, I think then over to you. If you can just maybe run the presentation, and then basically the floor is yours.
Okay, thank you. Thank you very much, Ahmed. Thank you to everyone participating. Thanks to Transnet and everyone that has organized this, Mr. Lanre Badmas, among many, many others. It's a privilege to be with everyone today, and I'm very excited to speak on this topic, on the navigability and management, sustainable management of the navigability of natural rivers. This is a topic certainly relevant to Africa, and we're really excited about all of the development activities that are ongoing in natural rivers in Africa. I've focused a lot of my career in Latin America, so I currently am living in and working with the Brazilian government on management of navigability of natural rivers in Brazil, in South America, but I did have the privilege and honor of working in the Gambia for a year on the Gambia River, as well as some other countries, including working on a bridge in Mozambique with the Millennium Challenge Corporation. And so certainly I feel very honored to be speaking to this group. So today we're really going to be focusing on, exactly as Ahmed said, how can we leverage natural riverine processes to enhance and improve navigation on those systems. So what we'll be talking about today is the key goals of PIANC Working Group 236. For those of you that have never been involved in a working group, I do want this to also be an opportunity to get motivated, excited about being involved with working groups as well. This is a great opportunity to share our expertise on a particular subject. If anyone ever has any questions related to how to get involved more with PIANC or in a working group specifically, feel free to reach out to me anytime. I think it's a very rewarding experience for those that are involved. So we'll talk about the goals of this working group. We'll talk about one of the contributions that we really provided to the overall riverine navigation community in the classification of navigable rivers as well. We'll talk about how we can leverage and use navigation planning and how that has evolved over time and where we really currently are as a practice. So one of the things that PIANC often wants to do is we want to take state of the art and really bring it to state of the practice. So how can we leverage the learnings, the everything that has been developed in this working group and really put it into practice? And so we'll be talking about the cyclical nature of how to manage the navigability of natural rivers. This is not a, we're not building a building here and then walking away and maybe do a little bit of maintenance here and there. This is really an active management approach to improving the navigability of natural rivers. And then we'll be talking about some examples of implementation. If we get a chance towards the end, we'll talk about some of the experiences we had on the Gambia River as well. So natural rivers, what is the objective of this working group and why was this working group relevant and necessary to be developed? So the working group report that has been completed, was completed about 2 years ago now, highlights the needs, the requirements, and the strategies to design a navigable channel in natural and undeveloped river systems. Now, natural is what does that mean? You know, we often have to really understand what exactly we're talking about. So what we specifically mean by natural river is a system that is not significantly impacted by hydrologic regulation, so operations of dams and other infrastructure that highly regulates or keeps flows constant, for example. And then also rivers that are not morphologically confined, so fixed in place due to river training structures or other interventions, canals, etc. You know, we look at kind of the spectrum of what a river can be as it relates to navigation. You know, some rivers are not navigable. They might not be large enough. They might not be deep enough. They might have too many waterfalls, too many impacts to be able to navigate. Other river systems are so large that they're just naturally navigable. I think of the Amazon River where we work, the Congo in some sections, and certainly various rivers throughout the world are just naturally navigable, even if there are not specific interventions put into place. But and then we also can take the perspective of a waterway, a developed river that has waterway measures, river information systems, potentially river training structures, certainly riverine ports and loading and unloading facilities. And so what interventions are necessary to bring either a non-navigable or a navigable river into what we would really consider to be a waterway? And what we're defining as a natural river is an undeveloped or quasi-natural river with natural hydrology and unconfined morphology. And these systems are dynamic systems. These exhibit natural river evolutionary processes. And we can see some examples of that. This is the Madeira River in Brazil, for example. These systems over time naturally evolve. We have the formation of side channels, which are generally unstable features of a large river system. Meanders migrate through the system. There's natural bank erosion and bar development. And so, you know, from year to year, if we develop navigation charts, collect bathymetry and develop a navigation chart of a particular river system, this will be changing from year to year. And so we really need to understand, number one, how much change these rivers exhibit. Number two, how we can really work with that natural behavior in order to maximize the navigability of these systems. Oftentimes fixing the navigation channel in one location in perpetuity, we may be fighting a losing battle without significant engineering interventions. And so how can we take some of these natural processes and really leverage that for navigability benefits? So a lot of the navigation challenges that we see are shoals, especially in crossings when the navigation channel goes from one side of the river to the other. Oftentimes we'll have some type of a sedimentation or shoal or shallow section of the river that is really oftentimes the bottlenecks of navigation in those systems. We have evolving and moving the navigation channel. That's a natural process. And we have hydrologic reliability over time. We may have excellent reliability during the wet season, but during the dry season, we just don't have sufficient drafts in order to move goods in shallow draft barges. And so reliability of natural rivers can often be a challenge as well. And so within the context of this working group, one of the first things that we really wanted to do is, where does this working group apply? And so one of the contributions that I'm very proud of is the proposal and the classification of navigable rivers that was developed. And so we have classes that range from A through E, Class A river being a natural river when it comes to the context of navigation. So these are the undeveloped and quasi-natural rivers with natural hydrology and unconfined morphology. So we look at the Brahmaputra River in India and Bangladesh, the Madeira River in Brazil, for example. Many examples certainly exist. A Class B river, we are calling this a trained river system. These are the open river systems that often exhibit natural hydrology. So we have a wet season, a dry season perhaps, but laterally the river itself is fixed in place. And so that prevents the lateral migration and some of the natural morphologic evolution. So many systems, we see this examples in Europe, in North America, the lower Mississippi River, the Rhine River, many others, of course, as well. Pooled rivers, these are the rivers that have locks and dams. So the lock and dam systems, they increase the overall depth, improve navigability of these systems, but it's really a stepped river system. We're calling this a Class C river system. That's something like the upper Mississippi River in the United States. Regulated rivers, perhaps, we're calling these systems that have regulated hydrology, perhaps, but the rest of the system might be natural. And so, you know, there might be very large dams, perhaps for hydropower generation, that regulate the hydrology and often shave the peak flows or increase low flows, really change and alter the natural hydrology, but there isn't any navigation training structures in place. And so we're calling these Class D rivers. And then Class E rivers are the highly regulated rivers. These are the navigable rivers that have significant alterations to discharge due to reservoir operations, as well as confined morphology. So river training works. An example of this is the Arkansas River in the United States. So when we compare the two extremes, a natural river where we just don't see a lot of interventions or measures or navigation structures to improve the navigability of these systems, compared to a system like the Arkansas River that has longitudinal training works. We have river training structures lateral to the perpendicular to the riverbanks. We have locks and dams in this system. We have regulated hydrology from offline and inline dams. And so these are highly regulated systems that require water management teams to regulate the river flow, as well as significant capital investments and maintenance investments to improve and maintain navigation. There's a lot of value in making those investments, of course, but it is certainly a significant capital investment for these systems. So as we're developing the working group, so I had the privilege of being the chair of this working group, and one of the initial questions that we had is, where does the guidance, where does this ultimately apply, and what is the vision of the application of this working group? And so we really developed this 2x2 matrix and asked the question, okay, we have existing river systems that may be regulated or confined, hydrologically confined, for example, with river training structures. So systems that have already had alterations. And then we also have natural river systems. And then the outcome after the recommendations of the working group are applied, for example, we'd say, what is the proposed river system state? What are the conditions of the river system if the recommendations of working group 236 are implemented? It could be a regulated or constrained. We could develop, for example, recommendations that use classical river engineering techniques, and that would ultimately take a natural river system and bring it into a regulated or a constrained river system. And so the resulting guidance of that approach would have been kind of traditional river engineering methods, okay? We also had the discussion of, well, what about existing systems that are regulated, are confined, are constrained, but still they'll maintain that regulation, but we're just making some nature-based improvements to those systems. And so that would be something that is the resulting guidance of that kind of combination would be a management and maintenance of existing systems that are hydraulically controlled by infrastructure. But there could be some improvements, for example. But what we really focused on is developing guidance where we are taking natural river systems and maintaining that natural behavior. And so we really are taking the focus of innovative navigability improvements that can maintain natural river system behavior. And that really is the focus of our working group 236. We did have the discussion as well of, well, what about existing systems and we bring back that natural behavior? And so that could potentially be a future PIANC working group. And so what we want to do is kind of want to walk through each of these, you know, kind of the traditional classical river engineering approaches that were previously applied and are still valid, certainly for natural river systems as well. Taking improvements to some of these systems, that's kind of the second version of river engineering within our profession. But we're really, I think, on almost like this third version of how to approach improving navigability of natural river systems. And that's really what we're going to be focusing here. And then we talk about the future potentially of another approach as well. Okay, so what are some of the classical river engineering techniques that have been implemented to improve navigation? Certainly dredging. Dredging is a measure that is very often used in order to improve navigation depths on our natural river systems. Also includes training works, also includes locks and dams. And there's been significant investments in these measures as well as others, aids to navigation, river information systems, among many other measures that have really improved navigability of river systems. One of the measures that we've used significantly in the United States and Europe is river training structures. Dredging is a continuous maintenance cost, and so if we can implement some perhaps a slightly higher capital cost through the construction of river training structures, but maintain a self-scouring channel through the implementation of these river training structures, that can over time ultimately lead to reduced costs overall. And so we developed redirective type structures, so spur dikes and groins, longitudinal training walls, various systems that redirect energy of the river systems away from the banks and really focus it into the navigation channel to promote a self-scouring system. And we also have resistive structures, and these are really our revetments, kind of our bank stabilization, where the river, it wants to erode into the bank, but rather than eroding into the bank, if we create a resistive approach at those locations, the only way that that energy can ultimately be used is to deepen the river, and so that improves the navigation on the outside of meander bends, for example. And these structures have been very, very effective at improving the navigation level of service and reliability of natural river systems over time. The purpose of the river training structures is ultimately to provide that self-maintaining channel and ultimately lead to a reduction in maintenance dredging costs. So we have a sediment transport capacity is reduced in both channels that are wider. So we have a sedimentation oftentimes in channels that are just naturally wider for whatever geologic reason and purpose. And then also in divided flows. We often find navigation challenges in divided flows. And so river training structures really are used to promote a primary navigation channel, fixing it in place at a deeper channel depth, even during the dry season. And again, that's very much improved navigability of these systems. Here's a couple of examples of river training structures that we build. Sometimes we build these landward side, sometimes we build these in the river itself, and so we have different river training structures that have really supported improved navigation of the Mississippi River, certainly where I have worked in the United States. Here's some more examples of river training structures. We started many of our structures in the United States using log piles and often willow mats to capture some of the sediment. So sedimentation occurs in front of these structures and ultimately leads to a deeper channel adjacent to these structures. And so again, these capital investments had really created a lot of improvements for our navigation. This slide ultimately shows why did we invest so much in river training works. So there's a lot going on in this slide, but on the Mississippi River, we basically look at in the bar charts how much dredging was done over time. And then as we started to build river training structures, so the total length of river training structures that had been constructed, how that dredging over time really was reduced. And so the capital costs of the river training structures ultimately led to a reduction in overall dredging. And that greatly improved the navigation of our country in the United States. I work for the U.S. Army Corps of Engineers. We partner with many countries, many river systems, and all of those investments had really improved the overall navigation and really contributed to the overall economy, particularly in the United States as well. And so that was kind of the first approach that was taken in our community of practice. Maximizing navigation improvements and doing it within kind of an economic framework where we maximize benefits at a least cost. But we really looked at the economics. We realized the impacts that has to the environment, certainly. And so we started to ask the question, are there ways for us to modify these structures and create more habitat? So structures, for example, that may have been previously constructed, we realized, we can maintain some of the navigation improvements. We could notch some of these structures, so put in some basically holes in some of these structures, create some islands, some great habitat here in order to both improve navigation in the main channel, but as well as provide really valuable habitat creation as well. And so this is kind of that second version of how we can create recommendations for improved navigation. Here's kind of a nice metric view of some of these structures. So really great and rich habitat, but also very much an improved river system. We did other structures in the Army Corps of Engineers. We constructed chevrons, for example. These are, again, creating a lot of hydraulic structure, a lot of scour in some locations, high velocities, low velocities, promotion of deposition adjacent to some of these structures. So just a lot of structure and a lot of benefits to the overall habitat. And so having that variability in both hydraulic conditions under high flow and low flow just really led to a lot of habitat benefits and environmental benefits as well. But it's still, again, maintained and improved navigation of our large river systems. So we had that kind of approach, and I think that we still continue to use that approach a lot in our developed river systems. But we started to really ask the question, okay, is there a better way? Is there a better way than, because all of these systems, both in kind of our version 1, the heavy investment river training structures, as well as version 2, where we're improving kind of the environmental and working with nature components of those river training structures, they still fix the river in place, and they still take a significant capital investment to implement. And so we asked the question, is there a better way for us to improve navigability of natural rivers without necessarily fixing the river in place? And so one of the primary recommendations from the working group is kind of a cyclical approach to maintaining, improving navigation of these natural river systems. So the question that we wanted to ask is, how can we work with the natural environment to promote the navigability of these systems and ultimately lead to navigation improvements? So we came up with a 4-step cycle, and the working group report 236, really each chapter is dedicated to a component of this cycle. So we oftentimes start in, we have a watershed, we want to improve navigation of a river system. We often start in some type of a planning phase, the development of a master plan, for example. And so we collect all of the information that may already exist. We come up with some master plan, we come up with some recommendations, we execute those recommendations. And then we ultimately monitor, how does the river behave? How is it behaving over time? And then we ultimately evaluate, how is the community and users, navigators, are we able to improve overall navigation, level of service and reliability? And then using that evaluation, we then re-update our master plan, come up with new recommendations, execute those recommendations, continue to monitor the system, understand the system, and continue this cyclical approach to improvement of natural river systems. So the structure of our working group report was made based upon this cyclical approach. So we talked about the planning phases in chapter 2 of our report. Chapter 3 includes all of the execution of different measures that can be implemented. So the dynamic river management and interventions. This is a lot of collection of bathymetry, includes morphological and strategic dredging approaches, some temporary structures, adaptable structures as well. And then we talk about the use of some of the previous classical river engineering techniques, river training structures that can ultimately be used not for the entire length of an entire system, but very strategically in order to improve navigation at some of our most critical shoals. And so that's really dedicated in chapter 4. And then we talk about in chapter 5, the monitoring and evaluation components and how that really goes into the feedback loop for our overall working group. Chapter 6 then including recommendations for the implementation of this working group, specifically to river as well as waterway managers. So in chapter 2, we really talk a lot about one of the main recommendations in the planning phase is understanding our systems. We really need to be collecting the necessary data to understand our systems. What is the existing navigation level of service? Where are our bottlenecks? How stable are our bottlenecks? How stable are these critical shoals? Are they permanent problems, or does this river, is it so dynamic that it changes over time? What is the sediment dynamics of these systems? Is there so much sediment in this system that if you dredge, that ultimately we're only going to have one season of benefits, or is this something that, if we dredge, we have many years of benefits because there's very little sediment in these systems? And so this really came up with kind of the technical, economic, and environmental feasibility of improved measures within the context of a master plan. But the key in the planning phase is really understanding the system to inform our programmatic decision making. This is just a picture of the 90% low water exceedance elevation on the Tapajos River, and then the identification of all of the various bottlenecks under that low water reference plane. And so that really helps us just understand where our problem areas are. In chapter 3 is really, I'd say, the heart of our overall recommendations in the Working Group 236. This is really kind of a three-way approach where we take hydrographic surveying and use that to update our electronic charts. We reposition aids to navigation as the navigation channel is evolving. And then if we're not able to maximize, or if there's still some critical shoals that are creating a bottleneck to our overall navigation, that's where we implement strategic dredging at very targeted locations. And not just the dredging, not just the improvement of depth of the river at these locations, but also where do we place that material in order to enhance and promote some of that natural morphological behavior. So for example, if we have a side channel, if we have a split flow around an island and the navigation channel is on the right side of this island, we might want to place that material that we dredge onto the left side of the island, almost promote some of that infilling in the side channel in order for us to maintain a deeper natural channel in the main navigation channel. So not just making the navigation channel deeper, but using that material in a way in order to promote and work with natural morphological behavior as well. And so we really need to make sure that we implement some of these different measures at appropriate times in our hydrologic seasons. So one of the recommendations is taking the first bathymetric survey at the rising limb of our hydrograph. We take, and this is where a lot of the sediment is ultimately going to deposit. We take a second survey as it's falling in order for us to really focus where we're going to need to reposition our aids to navigation and or dredge. And so we kind of talk about planning surveys as well as kind of execution surveys for making decisions as well. And so understanding the hydrologic behavior of these systems and knowing which measures to implement in order to really get ahead rather than respond to some of the navigation challenges. Being able to predict where we would have navigation challenges on these systems so that we can mobilize early some of the navigation improvements such as dredging and repositioning of the aids to navigation. This really goes through a couple of different approaches. We first need to collect the data in order to do this. That's the bathymetry data, the topography data, the hydrology, and the sediment data. We then analyze that data specifically in what we call a trend analysis. So if we're noting that we're starting to see more and more deposition in certain locations over time, we really want to be able to predict where we would expect to have shoals and navigation challenges during the low water season. So we do that during a trend analysis. We also use sediment transport models in this approach in the analysis. Those analysis, the numbers that comes out of those analysis is certainly useful, but I think that one of the most useful things of doing these types of models and analysis is a really informed waterway manager where they really have knowledge of the system. So you start to really build intuition of these systems and are able to start to forecast some of this morphological evolution as well. And then ultimately we can develop and implement the interventions. So particularly morphological dredging once we can understand those systems. But rather than being reactionary to when these problems developed, we can be proactive on these systems. And so that's really one of the goals of the Working Group 236 as well. After chapter 3, which goes into some of that dynamic river management behavior using repositioning of aids to navigation and dredging, we do talk about the value of some classical river engineering as well, but we put a little bit of a different twist on it. We look at, are there opportunities to really focus on low cost and temporary structures in order to accelerate some of the natural behavior of these systems. And I think that this is a really great example of channel suppression using porcupines on the Ayeyarwady River in Myanmar. So a series of structures ultimately to slow down the hydraulics, reduce the energy in the side channel, promote some of the deposition in this location, and ultimately lead to self-scouring of the main navigation channel. So these side channels are often unstable. If we know that these are going to fill in naturally, perhaps in 10 years, is there something that we can do in order to accelerate that process? And so slowing the flow down in these side channels is one method that's proposed as well. On the Madeira River, where I've worked quite extensively, we talk about some temporary, adaptable, and flexible training structures. It's an interesting system. We have a lot of wood that accumulates at some of the riverine ports. And within the master plan, we really discuss, utilizing this wood in some of the side channels in the same type of a process in order to, again, promote the deposition of that material in a side channel so that we can ultimately have deeper navigation, self-scour of the main navigation channel as well. And so, again, this is really working with nature. This is using the existing resources of these systems in order to maximize the benefits of those systems. Chapter 5, we then discussed the monitoring of the program itself. And we really talk about monitoring in two ways. Number one, how is the system evolving? So some of that trend analysis again. How does, from one survey to another, how much change do we have? But then also, how is the system responding to some of our interventions? After we dredge, how does the system respond? Do we have multiple years of benefits from that dredging? Is it creating larger benefits? Does it promote a deeper channel? Is there something that we can do based upon that information and the monitoring that we collect in order to more strategically dredge or put in some of these temporary structures? So here's kind of an example of the amount of tonnage that is transported on the Madeira River. Before and after the morphological dredging campaign, there was already some increase in this system, but we really were able to increase the navigation level of service after the morphological dredging campaign was implemented due to a higher navigation level of service. And so once we kind of reach that maximum annual transport based upon what can be transported during the wet season, that morphological dredging campaign really helps us improve the overall navigation of the system. And so we need to monitor that. We need to make sure that we can track those successes as well. So one of the systems that we were fortunate to be able to apply many of these techniques on was on the Gambia River. So many of us are very familiar with the Gambia. It's the river itself is really the defining geographical feature of the Gambia. Some of the initial estimates showed that if we were able to convert a lot of the east-west transport of goods from the road network onto the river itself, there can be anywhere from a $7 to $17 per ton of direct benefits in savings due to the efficiencies that would be provided by transporting on the river system. And so currently we have a multimodal transport context, as we always do for our supply chains. And so the port of Banjul in the Gambia receives about 2.2 million tons of goods per year. There's about 500,000 tons of exports at the port of Banjul. And then we have about 300,000 to 600,000 tons per year going east-west in the along the road networks as well as some riverine transportation now. And so we really identified, okay, what are some of the bottlenecks and what are some of the opportunities to apply some of the recommendations and measures, the types of measures that were found in Working Group 236 to the Gambia River, for example. So one of the transport challenges on the Gambia River is really underutilization of the River Gambia, including the over-reliance on roads for cargo haulage, contributed to the higher cost of cargo transport, limiting its potential as one of the Gambia's critical growth engines. And so we really wanted to identify, okay, is there a way for us to leverage the natural river behavior of the Gambia River and maximize navigation reliability of this system? And so we looked at, and this is when I was working, I worked for the Army Corps of Engineers, but I took a year working with a development agency, the Millennium Challenge Corporation, and really looked into applying some of the recommendations from this working group report. So we found, okay, what is the overall problem statement for this system? So, you know, we really looked at this within the context of a problem tree. The way that we can look at this is, you know, the consequences up top, the root causes at the bottom, but really the core problem, the transport core problem, was underutilization of a very efficient mode of transportation. Is really the core challenge for that overall study, that overall plan. And the question is, well, what is the root cause of that underutilization? And so we don't have access. Businesses, users, transporters don't have access to use the River Gambia, for example. And so then we ask, why is that? Why is that? So some of it is to do with some of the infrastructure challenges. Some of it has to do with access to capital, access to finance, some other purposes, things like this. And so we really want to take a comprehensive look at the overall problem. But ultimately, the consequences of this problem is a reduction in efficiency and a higher transport of goods and a higher cost of goods. And so we really found that, you know, implementation, you know, the availability of training the entire River Gambia may not be an economically viable option. And so we started to look at what are some of the opportunities for improving the River Gambia for navigation, utilizing some of the recommendations from Working Group 236. And so some of the concepts development, and this is really, when we look at the cyclical nature of the recommendations of Working Group 236, this is really at the planning stage. And so since it's relatively early on the development of the project, we're really focusing on, okay, what river navigation services can first be implemented. So the hydrologic and bathymetric data collection, the development of the electronic navigation charts, aids to navigation, dredging some of the critical shoals. But we don't recommend the large-scale river training structures that have been implemented on many of the European and North American rivers as well. Any multimodal transportation system also needs the riverine multimodal hubs. There's other working groups that have really focused on the planning of riverine ports as well. And so Working Group 236 really goes hand in hand with how do we connect the transport of these goods on these improved river systems to the multimodal ports and the multimodal transport network as well. And so we also included in the planning phase in the master plan the riverine multimodal transport hubs as well, which includes the berthing areas, the cranes, including containerization on shallow draft barges. And so we're able to identify and showcase how this mode of transportation ultimately would lead to an economic benefit overall by leveraging the natural river system that already exists, implementing some of the navigation river services, and then also the construction of a couple of navigation riverine ports as well, one at Basse and one at Ferrefena. And so, I think that this was a really great project to showcase how a lighter touch, rather than a full development of the entire system using full river training structures, locks and dams, all these other very high capital costs, we were able to demonstrate that level of capital cost may not be necessary for this system, and we're able to demonstrate that this is a consideration, leveraging the natural river behavior of the Gambia River. Within any project, we really need to look at how it's, again, connected to its multimodal systems. And so we also identified the port of Banjul as having capacity limitations, since all of the goods that we'd be transporting on the Gambia River would ultimately be transshipment onto shallow draft barges to go upriver, or vice versa, anything produced in the hinterlands coming downriver on shallow draft barges, ultimately for international export. And so we identified which the port capacity limitations, especially related to additional berthing space, storage areas, among some others. And so, again, whenever we talk about the river, we always have to look at how it fits within that broader context. And so Working Group 236 was a very important part of this project, but there's also, of course, many other aspects related to a project like this. So in conclusion, one of the guiding principles as we develop the recommendations for Working Group 236 is that the world's remaining natural river systems are a limited resource, and maintaining that natural river behavior and value of these systems was ultimately really guided a lot of these recommendations. We recognize some of the challenges that have occurred due to overdevelopment of many of these systems as well. And so we really promoted and identified working with nature principles, which provide a higher navigation level of service at a lower cost than some of the classical river engineering approaches as well. And so it really is that win-win kind of sweet spot that we wanted to make sure that we found as well. It does create a requirement to invest in strong data collection programs, especially in bathymetric and hydrologic data, because we really need to understand our systems and respond in real time to improve the navigation level of service. The only way we can do that is by having the data. We have to be able to make sure that we have in real time enough information to make those types of decisions, and then monitor the systems and understand how they respond to interventions so that we can ultimately optimize the design in that next iteration of the planning cycle. And that was another key conclusion from the working group, is that this is a cyclical approach. Whenever we deal with a dynamic system, it's not a construct it and forget it. We really do need to make sure that we invest in those programs, continually evaluate, continually replan, and update our master plans as we learn more information, as the system changes, and as those interventions are implemented. So with that, I'd just like to say thank you. I really like this quote. This is not my quote. This is a quote from one of the partners that we've worked with. And it says, an investment in waterways is an investment in the environment. And many of the working with nature principles that we discussed today, I really believe that that's a true statement. I'm very excited that Working Group 236 is now published and can be implemented on many of the world's remaining natural river systems for improving navigation. So with that, I'd like to say thank you, and I'll turn it back to you, Ahmed.
Now, thank you, Calvin, and well done on the presentation and information that you shared with us. A lot of very important points that you highlighted there, which I would like to then also then explore further. And yeah, so I mean, rivers are very important to a country's economy. I think you highlighted that in some of the examples, and what's also very important, and I think especially for the African context, with one of your final slides, to say that you don't need to do a full-on river training system. You can get away with a few minor changes, and that becomes very, very important, for Africa, because finances are, a bit hard to come by, and things, do get a bit expensive. So do want to look at, more cost-effective, means and measures for, African countries as well. Okay, so Before we jump into it, so just from my side, just again, thank you for the very insightful presentation. We'll move on to the Q&A, but before we go there, I do have just a few polls I want to run, some questions to get your insight. What I've been sharing in the chat, I've shared now the link to the PIANC membership. I shared the link to our WhatsApp group, so we do have a WhatsApp group. Please feel free to join. I mean, you can come and you can also then post questions and comments related to waterways. So even if you don't cover anything now, there is a WhatsApp group. We can always cover things on that, and Calvin is on the group as well. So we're quite privileged to have him on the WhatsApp group. So I'm going to launch the first one now. It's more just a rating, just to rate us. Maybe, but maybe it might be a bit early, but I just want to get all the polls out the way. So the first one just relates to a rating. Yeah, so you can rate us so we know, how we are doing. You can always come back and answer it later on. Maybe I might be launching a little too soon. But do rate us. We'd like to get your views and opinion as well. So the first question that I'll be launching, and towards the end, then Calvin, I'll just call you in just to maybe comment on the results. So the question goes down is what is the single biggest benefit you want from better managed river waterways? So we've got a couple of options there: reliable transport, lower flood risk, protect natural community, nature or communities, local job tourism, or I'm just here to learn. So please feel free to participate, colleagues. So we also then submit my answer there just to get things going. So that's the one poll. The second one is now dealing with which first steps feel most practical in your context. So let me just launch that one as well. Just give it a few minutes for the other responses to come through. So let's just wait for that. Okay. Then the second and last question, which first step feels most practical in your context? Share better depth, survey info, improve markers of buoys, fix known shallow points, uh, community benefits briefings and feedback, or not yet sure. So if you can just submit your answer there as well, then we'll come back. So the polls are in the chat. You can just go there and just have a look and then just then select your answer and give us feedback and we'll comment towards the end. So in the Q&A portion, colleagues, I've got a few questions. We've got now, obviously, we'll be talking to Calvin. We're talking to Jean-Marc. And Jean-Marc did mention that there was a colleague of his that worked on the Congo River. We'll also then pull him or her on. I'm not sure yet who the person is, but Jean-Marc, I'll allow you to introduce him just now. Him or her. Yeah, so we'll have a conversation. I've got some questions lined up from my side. Again, from yourself, colleagues, do put up your hand as well. I did see there's a few questions and comments coming in through the chat as well. Jean-Marc, Kelvin, if you want to respond to them directly, you're more than welcome to as well as we go along. So let me then start. Jean-Marc, I was going to just call you in. And noting that you had also from your side, I mean, you are a economist within the river system. You've also been quite key in working group 141 and 142 that looked at standardized minimum dimensions for rivers or navigation in rivers, and I think then the second one was more on the standards, not standards, the performance indicators. So that was the 141, 142. And when I look at them, then I feel they almost form the foundation of 236, where then 236 also then take all of that and start looking at it more from a nature-based point of view. So with that in mind, Jean-Marc, just to maybe give your comments and your views regarding working group 236 and the presentation from Mark, Calvin, and what key lessons can you highlight for us, or just things for us to keep in mind from your side, Jean-Marc?
Yes. Well, I think the best thing everybody can do is to download this report and read it closely, because it has so many aspects that go deep in detail on that subject. But I would like to draw the attention to the African case, because most of the natural rivers in the world are in Africa, or rather most of the big African rivers are natural rivers except Zambezi. So this report is of great interest for our colleague from Africa. When you look at the summary of recommendations, you find that you have to know the chronicle of the historical evolution of the rivers. That's a vital point. You may use satellite photos and try to understand the river, but if you don't have the point on the ground where this level is monitored constantly, you will not be able to understand whatever of the evolution of the river. So this hydrographic survey is essential, either on the shore or in the river itself. And that is vital because there can be so many errors. These data have to be accurate. If the data is not accurate, you may have a lot of misunderstanding of the behavior of the river. So, for instance, one gauge can be wrongly referred to the levels, and it may be 1 or 2 meters above the normal or accurate figure. So that has to be taken into consideration and closely monitored. The second point, which is touched there, is the adaptation of the rivers to climate change. I have to be very cautious about that because 40 years ago, there was the Sahel problem, the drought in the Sahel, and everybody was saying that the rivers will dry and disappear. But now we see that, for instance, the Lake Chad is rising again. And we can see that some of the rivers that were supposed to diminish their flow are still running quite well, such as the Ubangi or rivers like that. So the worst is not always sure. So you have to closely monitor that change, that adaptation to the climate change, because it may at times just reverse. Because, for instance, if you have more evaporation, that may also lead to rain in other places, which will compensate at some other place. Well, and that complicates the story. The report proposed the implementation of a cyclical approach of navigability improvement measures. The monitoring is extremely useful, of course. The evaluation also clear with this possibility of adaptation to climate change. Planning and execution is, well, clearly stated. The point in this report is the sustainability of navigability improvement, and that supposes to work with nature. because in a natural river, you have to rely on the work of nature to help you to develop this navigability. There is also local improvements with local techniques that may be useful. I'm not very conversant with that, but I know that, for instance, in India and Bangladesh, there were so many useful local techniques which have been used and are still used to improve navigability on those rivers. The Brahmaputra, for instance, is one of the biggest natural river of the world. It is untrained, and it's shifting channels now and then. It's a terrific river to look at. At places, you see the river changing course step by step, meter by meter. So it's incredible. Well, what can I say more? The main recommendations are to, and that comes again to one of my points, it's to establish and manage or improve a hydrographic service. That's for sure.
Yeah.
And in operation and maintenance of aids to navigation, that's for sure.
Yeah.
And one of the points that could be developed, especially in rivers when the traffic is not yet that much developed, it would be the use of this, how do you call that? Dynamic charting. Dynamic charting would be to make a sort of self-induced or self-filled system of charting. That would be one system like that is implemented in Europe, but
yeah,
I think it is mostly in developing countries that this system should be developed. When a convoy, a boat is moving on the river, it has to have an echo sounder, and these echo sounder readings should be reported by satellite to a central location, so that the soundings can be plotted now and then, so that
everyone has access.
Yeah, this will teach the way to go to the others, and that is an excellent system to implement. It may not be accepted by everybody, but because they say, oh, that's my knowledge, I give my knowledge of that part of the river. But at the same time, they will benefit from the knowledge of others.
Yeah.
Because you see, on the Congo River, I have seen a case. There is a huge variation of levels in the pool, which is near. And if you miss or if you touch a sandbank, when the level is getting down, you will be there for more than 6 months.
Yeah.
You cannot go out. It goes down by meter over a single night, and you are stuck and will never be able to move. So even in a huge river, you have
Restrictions.
which are dangerous, and yeah, that's the thing. Okay, and of course there is a lot of training to be done on all cases.
Yeah.
Um, we have one participant, Jamel, who also knows a lot of the rivers of Africa, especially of the Congo, and maybe he can have words if he please.
Yeah. I think let's call in. If we can just put up his hand, and I'll just pull him through. See now. Okay, there, I got you there. Let me make you presenter as well. Let's go, yeah. Make presenter, so we'll pull into the discussion. Okay, Jamel, you can come through. I think you just unmute on your side. And just share your comments, your views. I understand you've done quite a bit of work on the Congo River. It's been quite a deep river as well. I understand at 200 meters in some sections. Just to share your views with us, Jamel. If you can just unmute your mic. There you go. Okay, we can see your mic is open, but we don't hear your sound.
Yes, thank you very much.
There you go.
Yes.
Yeah.
Okay, it's work now. Hello everyone, thank you very much, Ahmed, and thanks Calvin for this nice presentation, and also John Mark for the recommendations. So I'm going to present myself very quickly. My name is Jamel. I'm a researcher, and I'm working almost from 5 years on the Congo River in terms of navigation. So I have developed a hydraulic model almost 2,000 kilometers on the middle reach, so it is to navigations, and also I have developed some applications that allow to improve navigation over the Congo River. But I'm going to just give some summary about the challenge that we have over the Congo and what we look to introduce in the reports as a recommendations. So the first one is we do not have data. So we are working on engorged basin, and this is the first issue with that not allow us to develop some hydraulic models and navigation maps also. And this is the first issue, that you are working on a very large basin, but you don't have data. Even if you are developing some models, so you don't have validation data, and this is the point that block you on understanding the dynamic, the hydrodynamic of the river. So my questions or my recommendations are, since we are working on engorged basin, and you can use remote sensing, for examples, to fill the gaps of data, can we introduce in the reports? I know that we have some experience with the Amazon and other maybe large river systems that they could also use SOT satellite or other remote sensing that could fill the gaps of data that allow us to develop models, and that will be very interesting. So second thing, that we have very old navigations. We have very old navigation maps over the Congo River. Statistics reports that we have 2,000 cases of death in the Congo River due to the river accident and incident. So we have a lot of work to do to improve navigation of over the Congo, but we have, as I said, some challenges in terms of finding data, good data to implement these systems and develop hydraulic model to fill this problem, or to have the solution of developing models. So my second point is, since Calvin have presented some results about the Amazon and other large river basin, I think there is a sort of similitude between Congo or African river basin, as John Mark has said, because Africa hosts the largest also river system over the world. We have the Congo, we have the Nile, we have very big, we have very large river systems. So is the reports and take into considerations this experience that we have on large river systems such as the Amazon and other large river system, and we can apply it now in our African continent. That's all for me. I didn't prepare to participate in
No, you're more than welcome
but
to know. It's good to have you here, and then we'll get to no, we'll engage. Let's
Thank you
engage.
very
I
much.
mean, you've got some experience, so let's engage on that.
Yes.
Kelvin, over to you. If you wanted to respond to some of those comments and questions.
Yeah, no, absolutely. I think that that's a great parallel. I think that you're absolutely hitting the nail on the head on that one. There's a number of parallels there. And what I think over the last couple of years, I think that the surface water and ocean topography satellite, the SWAT satellite, has been an absolute game changer for our field because we now have for the first time, very high resolution elevation data for rivers, for large rivers at least, large rivers, reservoirs, etc. And so that can be excellent data used for calibration, validation, like you're saying at least. We typically are able to have data every couple of weeks on different systems, and so we can really start to develop, even in ungauged watersheds, at least the hydrograph elevations for our large river system. So definitely encourage you to look into the SWAT, the surface water and ocean topography satellites. I think that that's something that can be certainly useful for some of those models. Now, it doesn't help for bathymetry. I mean, nothing replaces the bathymetry of these river systems when we start talking about building some of those hydraulic models and things. So that certainly is a challenge. And like Jean-Marc said, you have to go out and collect that data, and it's important to collect that data with a high level of precision and accuracy. But in terms of some of the calibration data, I think that we're getting, even in some of the ungauged watersheds, I think that some of the satellite-based data is now starting to become very, very practical and useful for these types of applications. And I've always been hesitant with the satellite-based data, because nothing can replace what we're seeing in the field. But this is really the first time that I'm confident on at least for the surface water elevation, which is such a key parameter in validating these models. So I'm glad that you brought that point up.
Yeah, no, thanks. Does it cover you from your side? I mean, sorry, I didn't get your name. Sorry, let me get here. I should make sure I get your name right. Apologies for that. Jamel. Yeah, sorry, I got your name there. Your comments, your feedback to that?
No, thank you very much, Calvin. Yes, it was very interesting. As you said, there's no place to replace data or in situ data with the satellite. This is very important. But when we do not have data, we need to have some models. But as I said, if we are this model provide the precision that we can apply now for navigation? That's where the uncertainty of these models came. It's very difficult because you have a very large river, you have a very morphology which is very challenging. Over the Congo, we have the Congo is divided on 3 main channels. You have the channel reach, you have the multi-treat reach, and you have the braided zone area. As Jean-Marc speak, you have braided with many iceland, and the morphology is very complicated. So we are working on developing some applications that allow I am working on some application that could improve the navigation with the minimum data that we have, but there is a lot of uncertainty also in applying this data when it comes to navigation, and that's what we are working to. That's what we are working on, and I think this is a very good point that we can integrate it in the reports, and that give us some feedback about this. Thank you very much.
Yeah. No, thanks for that, Jamel. So just on that, Calvin, obviously now one would keep in mind that I'm sure you probably saw the same parallel on the South American side. Getting data is not difficult to come by. So then it all comes down to who's then responsible. I'm sure it should be some kind of government official, government department and maybe from some lessons on the South American side. I mean, how did you manage to close a gap, or what advice could you give, back for the African context?
Yeah, so even this working group was really came from that realization. So we were doing a number of feasibility studies here in South America on improvement of large river systems. And really the main conclusion from a lot of those feasibility studies was, yes, there's a number of physical interventions that can be done, but the biggest value, the biggest bang for your buck will be in the investment of data collection programs. And so the Brazilian government had set up a hydrographic survey collection program, monitoring program for really all of the federal river systems. So that was really one of the outcomes of that work, and that has proven to be extremely valuable for making decisions. Ultimately, we need, as decision makers, that information in order to make valid recommendations. We're very lucky, at least in the United States, where any data that is collected that was collected using taxpayer dollars, that becomes public information. That must be shared.
Yeah.
That's not something that can be held on tightly. And so we end up, I think having an open culture of data sharing is also extremely important, because I think that everybody wins in that context as well. So because then we can really start to compare and contrast these different data sets and understand the differences. But that's kind of some of the history of why that became such a large priority in a lot of these studies, as well as the Working Group 236.
Yeah. So it's essentially, I mean, the government needs to get involved, and then the responsible departments need to get involved. And yeah, so Jamal, maybe on your side, I guess it's just a matter of then reaching out to the government and then pushing them on that. And then you'll have to, when it comes to governments can be, and I think it's the same all over. The government is slow at times, so it's just a matter of just continuously pursuing the agenda. But I see there's been some comments in the chat as well. I'm mindful of time as well, colleagues. We may just maybe run 5 minutes over if you don't mind. Just stick on this for 1 or 2 extra comments. So I'm going to jump straight to the chat, and I'm just going to pick up from the bottom, just some comments. So there's one from let's see, from Richard. Indeed, in India and Bangladesh, temporary bamboo structures are used that trigger natural erosion processes in the river channel. It's called bandling. So I'm sure you're familiar with that, Kevin.
Yeah, I appreciated that comment in the chat. Yeah, that was referenced in the 236 report as well as an excellent example of temporary structures. It's oftentimes that may only provide 1 year of benefits, but the costs are very low to implement those temporary structures. They're natural, and so it's a great option because it makes a big improvement to navigation. So appreciated that comment.
I think the next one is also a comment/question, and then I might just want to add on to that because I had maybe a related question. So it comes from Faisal. What about the impact on rivers caused by untreated sewage, industrial waste, and mining effluent, especially in Africa? So I guess that is a problem for us, and I'm sure you would have seen a similar on on the side. On the South American side, and then obviously how do you manage that? And what I wanted to raise early on is that I was going to raise a climate change question, but I think Jean-Marc responded to that. But for me, what I found very interesting, I know especially working in rivers, and especially when you have your environmentalists that come on board, they can be very specific, and rivers are quite sensitive at times, and it's the whole big environmental agenda. So I guess now coming and looking at the sewage spill, industrial waste that speak to the same environmental agenda. And I think what Jean-Marc also alluded to earlier on was that you need to be very careful in your planning because you don't want to also cause the opposite of what you're trying to do. So even just comment around that, the one question by Faisal, and then the sensitivities around working in the river, and then I mean, are you not at risk of causing major environmental impact?
Yeah. I think that's a great comment. One thing that I'm often I find to be very important to communicate is the low impact of riverine transport on the environment. I really do like that quote: an investment in waterways is an investment in the environment. Navigation, utilizing the river for navigation, it's a non-consumptive use, right? A lot of these other features, the sewage, the industrial waste, the mining effluent, etc., the navigation sector responds to that, but it's in terms of the navigation sector's impact to the overall riverine conditions, it's extremely low. And in fact, there's a lot of benefits because of the reduction in emissions when you compare that to roadway transport. And so there's a lot of environmental benefits of really investing in the river systems for navigation. And it's a non-consumptive use. We really look at rivers as kind of integrated water resource management, right? How can we utilize water resources, which is a limited resource, in the most effective way possible? And in terms of the various uses of water and impacts to water, riverine navigation is extremely low impact and extremely high benefits. And so these are the types of sectors that we want to really make sure that we're investing in. But yeah, some of the challenges related to waste, oftentimes that's one of the last types of capital investment improvements in some of these types of systems. And so, that's definitely an initiative that should continue. But the good thing is that the navigation sector isn't really impacted by it and doesn't really contribute to it. But those are very, very important considerations as well.
I guess it's more for river authorities. I mean, they need to have to take care of that. But I guess at the end of the day, it's a joint venture between the different authorities in monitoring the river as a whole, and it's just keeping abreast of that. Okay. I don't see any further comments, questions, or there was one, but I think it was just there's Jamel just responding back to one question. So just quickly jumping to our poll, just to have a look. So again, just thank you to everyone for rating us. So we're getting a 4.7. So well done, Kevin. So that's your KPI.
All right. Yes. Well, thank you. Thank you for the opportunity as well.
Yeah, no, thanks. So looking at now the first question, let me just go back here. What is the single biggest benefit you want to from better managed rivers and waterways? So there, the highest was on 42% on reliable transport, and followed by protect nature community. So that's what the audience feels in terms of that question. The second question now, which first steps feels the most practical in your context? So we had a 63% on share better survey depth and info. So that I think is quite straightforward. I mean, if you look at Jamel's comments and highlighting the criticality of not having the right data, and then yourself as well, and then John Mark also mentioned that. So it just goes to say that everyone thinks the same, that you need that data to do that. So yeah, just your comments and views on those polls. Kevin?
Yeah. Comments from me. I mean, it's interesting. I think it's great to see these responses. I think many of us on this call are certainly interested in waterway transportation. So I think that's why a lot of the answers are really focused more on that as well. But again, I think that we all recognize the value of these investments into this system. And so it was, I think that's like you said, fairly straightforward and good to see those answers.
Yeah. No, thanks. Okay, I don't see any further comments, questions. Then so what I'll then just do from my side, it's let me just go through my notes. See, was anything else I wanted to look at? Oh yeah, here's the one question I want to raise. So the new thing these days, Calvin, is now you've got the whole advent of AI, smart technologies, and so you've got the whole nice thing of machine learning and whatnot. Is that something that in your space with respect to river management that you've had a look at, or how does it come into context with respect to working group 236?
Yeah, it's interesting. I'm really fascinated with the advancements in new technologies and AI in the sector. I certainly think that there's a lot of opportunities to leverage it for some of the modeling, especially some of the comparison of data, some of the trend analysis. I think some of the work there has been fantastic. But in terms of replacing our jobs, it's been interesting reading some of the different articles that are out there. The transportation sector is one of the sectors that's probably least impacted by AI. Let's say we still have to transport goods. We have so I think that we are so well positioned to be in a sector that can leverage this great technology and really enhance, really use it for understanding these systems and modeling these systems and coming up with optimized design solutions. But we still have to go out to the river. We still have to go out and actually do the transportation, do the projects, and do invest in the infrastructure. So I'm optimistic that both it's going to benefit our sector and not replace the jobs of our sector.
No, look, I think the way I see it, it's an enhancement and giving you a wide perspective, one that you may not see immediately. Just some thoughts that come to mind is that assuming in an ideal world you get to put sensors along the riverbank. Maybe we've got your marker buoys. You can double them with echo sounders. So you dynamically and consistently monitor the depth of the river. And maybe even as Jean-Marc was saying earlier on, they must put it on the ships. I mean, if you're sharing, on your boats, sharing the data live, it doesn't hurt anyone, and I mean, it doesn't really cost you anything. So in my mind now, if you had something like that, so you dynamically have a live model where you can, in a live environment, see what's going on. What would be interesting to look at is that if you could then tie that back into a river, not river, your weather system. So we've got live, data from, weather falling and how does that impact the river flow. And not only that, if you can integrate your ports into that. So you've got ships coming in, ships going out, and having a look at the ship turnaround time, together with your road network and rail network, where there's intersecting nodes. And once you've got this bigger sentient type system going on, and you can better streamline flows and whatnot. And then just say, for example, say you've got some adverse weather on a river. You've got either river in flood or you've gone into drought. How does that now impact your other transport corridors along the way, upstream, downstream? So I mean, there's those interesting dynamics. For me, it's a much more broader thinking when it comes to AI, and then just a different application of the tool that I think for a single person or team of individuals, it might be a lot of work or too much to comprehend at a time, and which now machine learning does tend to crunch that numbers very quickly for you. So yeah, no, it's just my comments and views just around AI and the use of it. It's just I guess for me it's the only limitation is your imagination in terms of how you can apply it. But it's still a new space. So for anyone, I guess it's always going to be daunting. But yeah, we'll see how that plays out.
Yes, but AI needs data.
Yeah.
If the data is inaccurate, AI doesn't have any use.
No, for sure. No, you'll need the data.
That's the stress we have to get on this data. And conversely, when the number of instances increases, then you can compensate the accuracy of the data by the number of occurrences. That may help in that dynamic charting.
Yeah, definitely. No, thanks, Jean-Marc, for those comments. So colleagues, we'll look at tying up. So I'll ask each of our guests today, just 30 seconds. What's the single most important message that you'd like to leave us with today? So Jean-Marc, let me start with you. What would you like to highlight and leave with us in 30 seconds?
Just once again, the accuracy of data, because that is the first step which has to be taken. And for the rest, a lot of good things can be done by specialists. There is no problem. Remember that if you want to use to deal with natural rivers, try not to use that much of dredging, because dredging is not natural. But on the other hand, by dredging, you can also help nature to work in the proper way. And that is the interesting aspect of dredging, which can be natural as well.
Yeah. No, thank you, Jean-Marc. Thanks for those wise words. Kelvin, from your side, your parting shots?
Yeah, thank you again for the opportunity to present on Working Group 236. Like we mentioned earlier, the natural rivers are a limited resource globally. The protection and leveraging and using natural processes in order to enhance navigability and extract what I believe to be the most valuable mode of transportation, the most efficient mode of transportation, is the guiding principle of this working group. And what we often see is natural solutions, working with nature-based solutions is not only beneficial to the environment, it's also oftentimes the most economically beneficial choice. And I love when we find those win-win situations. So thanks again for opportunity to
anytime.
present.
Thank you, Calvin. Definitely a win-win. Let me then also pull in our surprise guest and then welcome guest as well. Jamel, would you want to then share a few words before we close? Apologies if I'm putting you on the spot. Go for it.
Yes, thank you very much for these opportunities. And as Jean-Marc and Kelvin said, I think in Africa we need to focus on our river, need to develop some approach, the models to understand the hydraulic behaviors, to just keep this river as a natural way, but we need also to understand this hydraulic behaviors, and with that we can improve navigation over these rivers. Thank you very much.
Thank you. And maybe at the same time, Jamal, I'm just thinking maybe we'll invite you to come and present also. We are running this every 2 months, and if you're up for it, maybe one of the future months. No,
that will be very interesting, and I think we have a lot of things to present about the Congo River. The Congo River is one of the largest rivers in the African continent, and it will be with pleasure. It will be very.
No, thank you for that. So through Jean-Marc, I'll get your email address, and then we can make a plan for one of the months in the coming year. No, thank you very much, Jamal.
Thanks. So.
Again, from our side, then, colleagues, what I'd like to do is I want to then, extend my sincere gratitude to our speaker and panel members, and yourself as the audience, for the engagement and discussion, and to Han Lichterringen, Captain Lonray Badmus, our PIANC Africa Committee for, assisting in the background and supporting this webinar. So much appreciated from all of you. Again, what we highlighted today, underscores the importance of continuous innovation, rigorous research, and responsible professional work that we need to do to address coastal and inland waterways. And so if you want to delve deeper on the topic, again, drop your question in the chat box. We haven't gotten to it. There is a WhatsApp group. You're more than welcome to engage on that platform as well. And so keep an eye out for the announcement of our next webinar. It might just be Jamel's presentation, but keep an eye out for that. We'll then plan the next one in 2 months' time. And if you're not yet a member of PIANC, we do encourage you to become a member of PIANC. We did drop all the links in the chat, so look for that link in the chat. Just a note, especially if you are from university, if you've got students or of students, PIANC does offer a 2-year free membership for students. So we encourage you to send out the invite to the students. It's great for them to get some insight into what PIANC is all about. At the same time, they do then get the benefit of access to all the manuals and a few other things. So we do encourage them, and it may then just spark that interest for that young individual to look into this waterways, both coastal and inland, as a career choice. And then so we are looking again, like I mentioned earlier on, is we are partnering with SciC Marine and PIANC SA. So Everyone from the South African group, I'm working on the side to try and get us some extra CPD points. Maybe as we go along, for CPD points within the rest of Africa, we'll also look at working with other organizations. So just keep an eye out for that for our South African colleagues. And again, yeah, just thank you once again to everyone for sharing your expertise. It's much appreciated from our side. And for those who will be celebrating Eid, if not tomorrow, on Friday, just want to say Eid Mubarak to our colleagues online. May Allah shower your families with barakah and happiness. And Ameen. And yeah, so eat something nice for me also, from your table also. And until next time, so keep on learning, keep on exploring. This is the PIANC Africa webinar. We'll chat again next time. Thank you. Okay, bye.